Hi, I'm here with Magnus Sahlgren, Head of Research for Natural Language Understanding at AI Sweden. He heads up the effort to develop large language models for the Swedish language. So, first question for you, Magnus, is how did you become interested in AI and NLU?
Yeah, it's a good question. So when I started at the university, I was mainly interested in philosophy, especially philosophy of language, and questions around, so what does it mean that something means something? What is the meaning of meaning, right? And I was really fascinated by the works of Ludwig Wittgenstein, primarily. And my professor at the university said that maybe you should actually try to read some computational linguistics. So I took some courses in computational linguistics, and then I understood what it meant. So in computational linguistics, you could actually do experiments around these kind of ideas. And so that's where I sort of drifted into this natural language processing field. And I've been working with various types of computational models of meaning since then, basically. So that means the predecessors to the modern type of language models, they're all based on essentially the same ideas on how language works, which we call distributional semantics. And that's my way into the AI field.
Okay. Now, are large language models on a path to artificial general intelligence, or will that require a completely different way of doing things?
Yeah, so what is artificial general intelligence?
Okay, you're asking, go ahead, you answer that question.
Yeah, no, so I don't really know what that is, but I do think that they are certainly one step on the way to something more general. Um, and since my take on this is that these modern models, they are still only following the same sort of theoretical frameworks that I have been working with in NLP for a long time, mainly distributional type of models. This is by far the most practically useful and promising way forward to more general types of methodologies. I do think that we will see more breakthroughs going ahead. We'll probably not use transformers in 10 years, but who knows?
Okay. So what makes your work possible today, and what will enable progress in the future? For example, are there new mathematics? Is it because there's a lot of data, or is it because we have better computers? What is it? What's the enabling technology, and what will bring it forward?
Yeah, so at the moment, what makes our work possible is that we do have funding, we do have competence, we can work with Swedish text data, and we do have access to compute, right? But the next steps will require just more of everything, more of funding, more compute, more data, better data. I don't necessarily think that we need any new breakthroughs in order to take the next steps. I think that we are on a path where these methods seem very promising. I think we need to scale them up to see where the limits are.
Okay. So you were a successful heavy metal guitarist before doing your studies that led you to where you are today. Do you use some of the skills you developed in music? I know there's musical skills, and there's also the fact that you're part of a band. And when you're part of a band, you sort of have a project together. Do you use any of the musical skills or the project skills in what you do today?
Yeah, well, first of all, that was a long time ago. In many senses, a different life, but no, I don't really think that I use anything from that period. Maybe that I'm more attuned to dissonance in different ways, but no, nothing else.
Okay, no, that's not the answer I was expecting. So in a guitar solo, phrasing is important. You know, you can listen to a country western guitarist try to play heavy metal, and you'll hear the country, right?
Yeah.
Okay, now it's also important in speech. You know, you can hear people's accents.
Yeah.
But one of the things we're doing today is we're reading a lot of text to train models. And so if you want to then make a speech interface, you can't just take a text model and add speech, can you? It seems you'd have to train on voice data to get the model to work. Can you speak to that idea that you're only getting certain information in text, and you're losing all that phrasing?
Yeah, I think you're onto something there, and that's related to your question on more general types of intelligence, right? I mean, text is a very sort of poor signal if you compare it to speech, right? So you can communicate things with prosody, with pauses, intonation. It's a much richer signal. And if you talk to linguists, they would probably say that speech is real language and text is just a manifestation of it, right? So I think, I mean, this is connected to taking the next steps. I think in order to build models that have a more sort of richer understanding of human language, we also need to include speech in that training data.
Okay, so you speak publicly and attend events around AI and large language models. I have to ask this question: are the parties at these events as good as the parties after a heavy metal concert?
Yeah, no, not really. Better food, maybe, better snacks, but not as good.
Okay. Okay, Magnus, thank you very much for your time.
Thank you.